Namaste and good afternoon to our participants joining us from India, and good morning to those joining from Germany. On behalf of the Indo-German Energy Forum Support Office, it is my pleasure to welcome you to the second webinar in our series, Pathways to Low Carbon Industry. This webinar series is being organized in cooperation with the German agency DENA and the Indo-German Chamber of Commerce. As countries strive to achieve their climate and energy goals, decarbonizing industry has become one of the defining challenges of the energy transition. Manufacturing industries account for a significant share of global energy consumption and emissions. Improving energy efficiency in these sectors is therefore not only a climate imperative, but also an important pathway to enhancing competitiveness, reducing cost, and strengthening energy security. India and Germany share a long-standing partnership in the energy sector. The Indo-German Energy Forum provides an important platform to strengthen this cooperation by facilitating the exchange of knowledge, experiences, and practical solutions between both countries. Today's webinar will focus on key pillar of industrial decarbonization, energy efficiency in manufacturing. We will hear about policy frameworks and experiences from the European Union and Germany, followed by a practical industry example on heat recovery from flue gases in the brick industry. These insights can provide valuable perspectives for accelerating industrial decarbonization and improving resource efficiencies. Through this webinar series, we aim to create a platform for a dialogue among policymakers, industry representatives, experts, and practitioners from both countries, and to encourage the exchange of experiences that can support the transition towards a low-carbon industry. I would like to express my sincere appreciation to all our speakers, participants, and partners for joining us today and contributing to this important discussion. With that, I would now like to hand over to Benedict, who will guide us through today's session and introduce our distinguished speakers. Thank you.
Thank you, Madhuri. Dear ladies and gentlemen, it is my pleasure to welcome you to this webinar on behalf of the German Energy Agency. Before we start, a few housekeeping rules. Please address your questions to the speakers via the Q&A section, which you find on the top right of the webinar tool, symbolized by a question mark. Today's webinar is about energy efficiency, one of the central pillars of the energy transition. We will have two speakers presenting today. First, my colleague from the German Energy Agency, Daria Oveschenko, will provide an overview of energy efficiency policies in Germany and the European Union. Daria has studied political science and is working on energy efficiency instruments in Germany and internationally at the German Energy Agency for more than 3 years. Afterwards, Professor Markus Heinthaler will present a practical example of energy efficiency improvements at the brick manufacturer Schlagmann Proton. The colleagues from Schlagmann Proton are also present today and are happy to answer your questions. Markus holds a doctorate degree in engineering from the University of Erlangen and is the professor for process engineering and plant technology at Deggendorf Technical University since 2018. After each talk, we will have around 10 minutes for questions and answers. And so without further ado, I would like to hand over the virtual microphone to my colleague, Daria. Thank you for your attendance.
Yeah, thank you, Benedict, and good afternoon to all of the participants, and good morning to those who are joining us from Germany. As announced, I will provide you with a short overview of energy efficiency policy framework in the European Union and in Germany. And I will try to share my presentation slides with you right now. As I see it, I don't have presentation rights. Maybe the organizers, you can share them with me right now, because I can't share my slides currently. Yes, now I have the rights, and you should be able to see my presentation slides in a second. Yes, so let's start what we'll talk about today. I will present you shortly the general orientation of energy efficiency policy in Germany, also the regulatory framework at the EU level and also at the national level. We will discuss different layers of instruments to introduce the energy efficiency policy, from regulatory measures, financial measures, to information and awareness measures. But before moving forward with those topics, I would like to shortly introduce you to the German Energy Agency DENA. Maybe for some of you are familiar with us, and for some participants, maybe you haven't heard about us yet. So just a short introduction, DENA, what we do and who we are. So the German Energy Agency DENA is a competence center for applied energy transition and climate protection. Then is also a public enterprise owned by the federal government. And since our foundation, we have been active in more than 60 countries. So we are quite international, and we have already implemented more than 1,500 projects. What we actually do, here some brief information on that. So we analyze the challenges towards climate neutral society and support the German government in achieving its energy and climate policy goals. We prepare strategic studies, provide policy advice at the national and, as we just seen, international level. And since our foundation, we have been developing solutions, putting them into practice, bringing together partners from politics, business, research, and civil society, following this holistic approach. And through these years, our network is became quite extensive due to regular organization of stakeholder dialogues and different exchange platforms with stakeholders. And so as you see, we work on a quite wide range of topics, from redesign of buildings and various aspects of energy supply to digitalization, innovation, and transformation of the economy. And when it comes to transformation of the economy, our department for industry, energy efficiency, and mobility is active. My colleague Benedikt and I represent today, and we implement projects that drive climate neutral production, energy efficiency, and develop strategy and policy papers on relevant topics. But also, in addition to this, we also are active when it comes to practical solutions. Our Center of Expertise for Energy Efficiency through digitalization in industry also is developing quite interesting hardware solutions combined with software. Maybe we'll have a chance to talk about it a bit later, but that's just a general introduction of German Energy Agency. And now I would like to move forward with the current topic of as a presentation, which is general orientation of German energy efficiency policy. This is the point I would like to start with, and here it's important to point out that since 2010, energy efficiency has been one of the central pillars of the country's energy transition strategy, and Germany has set itself a very ambitious goal to cut its primary energy consumption in half by 2045. And here, important role plays not just producing cleaner energy, but also achieving the same economic output while using dramatically less energy overall. So to reach this goal, Germany develops its energy efficiency policies through collaboration between political leaders, businesses, scientists, and civil society organizations. So the key point in this path is not only about changing where energy comes from, it's also about changing how efficiently energy is used across the entire economy. And here I would also like to point out, and probably you also already have this question in mind, how do you actually convince millions of people and thousands of companies to use energy more efficiently? And so Germany's preferred answer is not to rely solely on strict regulations. Instead, Germany tries to make energy efficiency financially attractive. So the government applies market-oriented instruments such as carbon pricing, financial incentives, and special financing models like energy performance contracting. For example, if company upgrades its equipment to reduce energy consumption, it can benefit not only from lower energy bills, but also from financial support from the state and avoided carbon costs. I will elaborate on this a bit later today. So in this way, energy efficiency becomes a business opportunity rather than solely an environmental obligation. And of course, market incentives alone are not always enough to achieve ambitious goals. That's why Germany also introduces certain regulatory requirements where faster action is needed. So overall, the approach, we can say this approach is a balance. Wherever possible, make efficiency profitable. Where necessary, support it with regulation. And here on the slide, you can see there are different layers of instruments to address the various barriers surrounding the implementation of energy efficiency measures. Therefore, one can differentiate this set of measures. We can see here four main pillars: information and awareness, also important regulatory instruments, classic command and control type regulations, financial supports, which are grants, preferential loans, and tax incentives. I will provide also some concrete examples so you can also understand how it works in practice, and also price signals. So now we will take a look at some of those instruments and how they are being actually implemented, and I will start with to talk about regulatory framework, regulatory measures for energy efficiency at the European, the level of the European Union. And so, as you see here, Germany's energy efficiency policy is embedded within a comprehensive European framework that sets the overall direction and the ambition for energy transition. What this slide illustrates is a multi-level governance approach. So the EU provides a strategic framework and regulatory direction, while Germany implements these goals through practical policies and programs. And an important development in recent years is that the focus is not longer limited to energy efficiency alone. Increasingly, both EU and German policies also consider material efficiency, recognizing that reducing resource consumption and improving circularity can deliver significant energy and climate benefits across value chains. So Germany's roles at the EU member states is to translate these European requirements and objectives into national legislation. This is reflected in instruments such as Energy Efficiency Strategy 2050, the National Plan on Energy Efficiency, and the Energy Efficiency Act. And now I would like to shortly demonstrate you how the EU sets the requirements and how they are being implemented at the national level in Germany. And in this regard, I would like to highlight the European Energy Efficiency Directive. It's one of the key instruments to regulate energy efficiency in the industrial sector. And at its core is the principle of energy efficiency first. So this means before investing in generating, storing, or transporting new energy, you should first reduce the overall energy demand. because we all know that the cleanest and the cheapest energy is the energy that doesn't have to be produced in the first place. And building on this principle, the directive raises ambition at the EU level. Member states must collectively achieve at least 11.7% reduction in final energy consumption by 2030 compared to 2020 levels. And for industry, this translates into concrete obligations. So companies with consumption about 23.5 gigawatt hours per year must implement energy management systems, while those about 2.7 are required to carry out regular energy audits. So overall, this directive turns energy efficiency into a structure, enforceable priority across industrial policy and investment decisions. And this was the example of requirements at the EU level. And now I will show you how they are translated into the national law in Germany. And to implement this requirement, Germany has adopted Energy Efficiency Act, which came into force in 2023. But important to note that it's not the only law that translates EU requirements at the national level. There are also other regulations, but since we are restricted in time, I will provide you just with a few examples. And this law also sets national energy saving targets, as you may see, which are quite ambitious. And for the longer term perspective, Energy Efficiency Act reflects Germany's climate neutrality pathway. And following the EU requirements, you see again, this law introduced mandatory energy management systems for companies. Also, it requires companies to publish action plans based on energy management systems or audit recommendations. It requires companies to avoid and utilize waste heat. And another key element concerns which this law is also regulating is waste heat. We will talk about waste heat more in with practical examples a bit later today, where colleagues will introduce some examples from the brick industry. But important to note that this act requires companies to avoid waste heat wherever possible and to recover it or make unavoidable waste heat available, provided this is technically feasible and economically reasonable. So we will see how it works in practice. And it's also important this law is currently under revision in Germany, and the draft amendment aims to align German requirements more closely with the EU Energy Efficiency Directive. That's why those thresholds, I tried to mark them in different color because they are to be changed, and the current draft proposes increasing the national threshold to the EU level. So the current objective here is to focus on regulatory requirements more strongly on energy-intensive industries by providing relief to the wider economy, particularly small and medium-sized enterprises, because you can see those thresholds for instance, for energy management systems, it's for companies which consume more than 7.5 gigawatt hours per year. But at the EU level, if you remember, it was 23.6. So the level of the EU is a bit higher, and this Germany the government wants to adjust with the new draft amendment. So that was shortly about we talked about the regulatory measures at the EU level, at the national level in Germany, and maybe now it would be interesting also to take a look at the industrial energy consumption in Germany, how it changed, maybe to trace the relation between the policies and how does it look in practice, and which influence those policies have. And we can see here that since 2008, Germany industry has reduced its final energy consumption. It is 15% below the 2008 levels, and At the same time, the economic output generated per unit of energy has increased. So this indicates a degree of decoupling between energy use and value creation. At the same, it's important to note here that there's the main success point that one can produce more while using less energy. That's the main objective of the German energy efficiency policy. But at the same time, it's also important to note that as this trend is not solely explained by energy efficiency improvements, there have been also some structural changes in the economy, shifts in industrial activity, and also exceptional events such as corona pandemic and energy crisis. But we can see also this general trend, which is quite positive for the industrial sector. So the key policy objective remains the continued reduction of absolute energy consumption alongside productivity improvements. And also it's interesting to take a look at the climate targets and the developments of greenhouse gas emissions reductions in Germany in the past years. And as you can see here, that following emissions reductions in 90s after in this post-reunification period in Germany, emissions remained largely unchanged until 2021. In the short term, increasing energy efficiency of industrial processes is maybe the simplest measure to reduce emissions from the industrial sector. The climate action program of the German government also foresees industrial transformation based on electrification, sector coupling, and circular economy principles. So these measures are needed to achieve the ambitious goals of climate neutrality until 2045, as you see on these slides. With this in mind, one needs ambitious measures that need to be implemented in the next years. But when we check the emission reductions that have been achieved so far, Germany is on the right track in this regards. And I will move to the next topic because we discussed some regulatory measures, and now I would like to shortly demonstrate to you also financial measures to promote energy efficiency in Germany. And one of the most important funding instruments
Could I just quickly come
Yes.
in and remind you of
Sure.
time? And to the participants, please take your opportunities to ask questions in the question and answer section, and we will address them shortly. Thank you.
Great. Yeah, thank you, Benedikt. I will try to make it short. So, as I said, financial support is also important instruments for industrial decarbonization. And for instance, this funding program for energy and resource efficiency in industry plays an important role. It supports investments that reduce energy demand, resource consumption, and greenhouse gas emissions, helping companies combine climate action with operational efficiency. You see on the slide, this funding is available for multiple technologies, cross-sectional technologies, process heat from renewable energies, and so on. And a key milestone was the May 2023. It's in this year the program was revised, and this update, revised version, strengthened support for industrial process heat decarbonization and expanded electrification measures. Important role also played the small and micro companies. They received better funding rates and to improve their access to industrial decarbonization investments. Yes, and of course, one shouldn't forget about information and awareness measures that also play an important role to promote energy efficiency and to show its importance and importance to use about the energy efficient energy use. Here, there are some examples how it can be addressed via specific tools. Since we are running out of time, I will not dig into it very in detail. And also one of the examples is the project energy efficiency and climate protection networks that facilitate corporate exchange between companies. So the aim of this project is that companies from various industries meet together, discuss the measures that they implement, and set specific energy saving goals for the whole network. And then they go to the monitoring process and implement the measures and save energy altogether. So this is also a specific tool that is being used by the government to enhance energy efficiency in the country. Yes, and I think I will stop at this point to save time and so that we also have some time for the discussion. Thank you.
Thank you, Daria. I will give a few seconds for participants to address their questions. I have not received any questions yet, so maybe I will take the chance and address a question to you. You mentioned that the energy efficiency framework is quite heavily debated in Germany at the moment. Could you maybe explain a bit more what are the contested issues and how you see the framework moving forward?
Yes, that is, thank you, Benedikt, for an interesting question, because it's quite a big discussion in Germany now. Because when the government introduces energy efficiency requirements for the industry sector via strict regulations, also one should take into account how economy will react. And in this case, if the Law and Energy Efficiency Act has strict regulations, the economy feels a bit not prepared, especially medium-sized enterprises. They always need support to tackle those requirements, to be able to implement those requirements. So now the discussion are mainly about those thresholds, how which companies should implement energy efficiency measures or implement energy management systems or energy audits, because now it's planned those thresholds will be a bit higher. So this obligation will be just an issue for companies with the highest levels of energy consumption. So the most energy intensive industries will have, of course, to fulfill those obligations, while medium-sized enterprises, they will be a bit relieved, since this regulations threshold will be adjusted according to the EU level. And at the same time, one has to achieve ambitious energy efficiency goals. So strict regulations, but also there's a need to recognize that medium-sized enterprises need support, financial support, funding support from the government. So in this way, how government officially communicates it, they are doing those changes with the aim to relieve the economy. This is one of the examples of what is being discussed currently.
Thank you. Thank you. I received a few questions now. The first question is, how are industries monitored and awarded to reduce waste heat?
Yes, so there is also there are specific instruments how to monitor the industries, also in regards to waste heat. We have also the established monitoring system in Germany to see how the energy efficiency measures are being implemented. And there are state institutions who are responsible for that, like BAFA. Benedikt, maybe you can help me to translate this into English. Those are institutions commissioned by the federal government to control, to install this control and check mechanisms to make sure and to ensure that the companies follow the regulations. And also energy intensive companies and they have an opportunity to get funding for their energy efficiency measures, also in regards to waste heat, as I presented today. So also in the framework of those funding programs, there are mechanisms where also DENA is quite active because DENA is participating in the project and implements the projects when it comes to the check of the companies that receive public funding to check the implementation of the measures. So our colleagues from DENA come to the companies directly, visit, and they are being demonstrated how the measures are applied, which of the regulations are followed, and then we take all of those documentations in our data bank and share it with the state institutions. So this is how it works. There are different mechanisms at the state level within funding programs and in general as well.
Thank you. And another question, in your opinion, which of the instruments that you presented, so for example, carbon pricing, financial incentives, the regulatory mandates, and so on, is the most effective in driving industrial efficiency, or is it really the combination of those?
Yes, as I already mentioned, Germany follows this holistic approach, so to say, not only strict regulations, but also financial instruments and market-oriented approach to support the energy efficiency measures and to enhance their efficiency. And I would say that it's a complex that makes it all work well all together, because when you differentiate just one instrument, it will not show the results when they work as compared when those instruments work in combination, because for instance, carbon pricing is a market-based climate policy that attaches direct financial cost to greenhouse gas emissions. And so anyone who burns fossil fuels must pay for the climate damage they cause. By making fossil fuels more expensive, carbon pricing automatically makes energy efficiency, insulation, or renewable alternatives more financially attractive. But as you see here, government didn't intervene here via regulatory measures, because government didn't say you have to reduce to this exact extent of your emission reductions, but there is carbon pricing mechanism which is market oriented. So carbon doesn't have the government doesn't have to intervene at this stage. So as you see, it works always as a combination, and as a combination it proves to be efficient. So that would be my answer.
Thank you. Thank you. Being mindful of time, I would now like to hand over to Professor Heinthaler. I thank you, Daria, and we will try to address the remaining questions via email after the webinar or after Mr. Heinthaler's presentation, if there is still time. Thank you. Professor Heinthaler, and I hand over to you.
Yes. So I'm choosing the correct screen and share it for you. I already got sharing rights. So I think it's shared now, as I'm also seeing it there. So also Bernhard Schmiedhammer, can you please switch on your camera shortly? I will also introduce you. Yeah. Yes, here you are. Good. So, yeah. So, thanks for the kind introduction, Benedikt, and also Daria. You gave some, remarkable points, which I will also take up in my presentation. As you said, it's one of the energy goals of Germany to avoid and utilize waste heat, and that's the perfect topic I'm presenting here. So, but before that, I also want to introduce Mr. Bernhard Schmidhammer, who is also joining the meeting today. He's more than 30 years now working with at Schlagmann Poroton, the company which has realized this heat recovery project. So I don't know anybody better that knows more of this company than him. I'm sorry, I have to excuse Mr. Thomas Frankenberger, who was originally also on the list. He was one of the leading engineers there, but he has to be excused today. Good. So let's see what Schlagmann, this brick company, did there at this site of Isen. So Schlagmann has several sites. I will point that out also in a second. And here we see the site of Isen and this heat recovery plant, what this presentation is about. That's already here in the back, so we can see it there. But first of all, a few words about Schlagmann. So as we have a lot of audience also from India, I'm showing also where we are located here in Germany. So you see the gray shaded area is Germany, and what is highlighted here in a dark gray shading, this is the lovely federal state of Bavaria. And if we zoom in now, so here in orange we see the 5 industrial sites of the Schlagmann brick company. So these 5 sites make Schlagmann the largest brick company in whole Europe. And what you also see is indicated in blue are the 3 teaching sites of the Technical University of Deckendorf, the Deckendorf University of Science, what is University of Technology, in German called Technische Hochschule Deckendorf. And as you see, Schlagmann and the university is closely located to each other, so it makes perfect sense to collaborate with each other. And that's what we are doing very successfully for 9 years now. So let me tell a few facts about our university, and then I'm diving straight into this project of the heat recovery system. So if we zoom in to Eastern Bavaria here now, so you see we do not only have these 3 teaching sites, which you saw on the slide before, but we have also 14 so-called technology campuses. So that's a dedicated goal of our president, that it's not all the campus activity is centralized on one campus, but we are going out to the industry. So everywhere where certain enterprises, industry is located, we build up a technology campus so that we have short distance or distances of communication and closer collaboration. So that's really a dedicated goal. And I myself, I am located at the European campus Rottal-Inn. Here you see our 2 university buildings. So the gray building is more for the lecture halls, and the white building is our lab building for mainly for educating our engineering students. In fact, we are quite a young campus. We were founded in 2015, so just 11 years old now. And you see we have a constant growth of student numbers over the last 10 years. So now we reached about 10 times the initial students. We have now close to 1,600 students at our campus. So that's quite a significant growth. And what makes us so attractive is that we are teaching all our bachelor, master, and master programs in English. So that's also very interesting and attractive for international students. So these 1,600 students are coming from about 110 countries in this world. So Vorkirchen is our campus is a very colorful place to study. So highly international there. And what can you study here? We have both bachelor and master programs, altogether 10 programs. And it's again the same goal of our president. We want to teach and graduate students in the fields what is needed in the region. So from the region for the region. So you see we have a strong health enterprises here. We have a large recreational area here in southern Bavaria. All this recreation means hotels, so we have tourism study programs. We have a strong industry, also like Schlagmann, so energy engineering is offered, and also sustainable buildings now. And for this bachelor program of building products and processes, I am the head of this study program. So that also fits to our close cooperation with Schlagmann. So, but now let's come straight to our project. So you saw this is, we are talking about the Isen site where this new heat recovery system was established. So I think many of you know that it makes perfect sense to, in a brick company, to reuse that hot air which is exhausted from the firing process of the bricks. And so the firing takes place at between 950 and 1050 degrees Celsius. So it makes perfect sense to utilize this waste heat, and it's typically used for drying the bricks also. So that means a heat exchanger makes perfect sense to be able to reuse this waste heat for the drying process. However, up to now in this site, this heat exchanger was, or this heat exchange was done with heat pipes, which we see here on the right. And as they are already, growing, they became older, and that means also the efficiency of the heat transfer was also declining. So that means we had an unused energy potential of the hot flue gases. Means also that for drying, where this reused heat was used formerly, leads to a natural increase of natural gas consumption. So more natural gas was then needed for the drying process. This, which is of course not the goal which we have today. So then the idea, of course, came up: how can we plan a new heat recovery system which solves such problems? And so the first expansion stage was then done in 2017. So if you install such a new or integral part of a production site, then of course the production has to be stopped, and that means you cannot produce and sell the bricks later. So the idea was to have this installations done when there are periodical shutdowns. So there are shutdowns typically in January, where all the maintenance of the whole plants take place. So these shutdowns were also used to refurbish and to do this retrofit also of the heat recoveries. So in 2017, in the first expansion stage, the new stack was installed. Here we see it also on the photo. This is the new stack, state-of-the-art, double-walled, freestanding, insulated. A new exhaust fan was installed. That's what is hidden here in the back. There was also priority on safety technology. So also in case of malfunctions, the materials have been chosen that also the temperature of the plant cannot exceed 300 degrees Celsius to not pose any safety issue there. There were also bypasses in the case of malfunctions realized, and so on. So safety was one of the utmost priorities in this retrofit. And this fluorine cascade absorber, which we see here in the back, this device is also a safety device. It makes sure that no fluorine in the flue gases will be released to environment. And the old one was already also outdated. So this absorber was then also upgraded. Good, and then the second expansion stage in 2018, this central air-to-air heat exchanger was installed. So here we see when the heat exchanger was lifted by the cranes and installed at the site. And when the heat exchanger was connected, it could be also, or installed, it could be also connected to the dryer and finally be started up. There is also a specialty about this heat exchanger. So as the flue gases also contain some volatile, toxic and acidic and corrosive substances, it is dangerous to come below the dewing point in that heat exchanger, and then you have this acidic mixture which can corrode your plant, and is also of course an environmental issue. So I will talk about that later, how this air circulation to prevent and avoid condensation is done. So, and this is how the final plant looks like. So you see here it's brand new, the photo from 2018. You also see the manufacturing company of these heat exchangers. So that's the company Helmich. And it's quite impressive to look at these numbers here. Since the start of 2018 until today, 117,000 megawatt hours of natural gas equivalents, energy equivalents were saved only at this one production site. And that means also if you save natural gas, then you can also save CO2 emissions. 23,500 tons of CO2 could be saved with that plant up to now within the last 8 years. Good. So, and due to this significant changes, Schlagmann was also nominated for the Energy Efficiency Award, which was handed over by the DENA. So out of the 142 applications from Europe and around the world, Schlagmann was one of the 3 nominated companies for this, yes, energy efficiency measures. Good, so let's talk a little bit about the details. What is so special about this heat recovery system? So here we see the kiln, the furnace of that brick production. So this is where the bricks are fired, and the hot exhaust gases, the flue gases, come here by the red pipeline. And to see what happens next, we also have a right side view here in the right figure. So you see the hot exhaust gases come with about 450 degrees and enter this central heat exchanger. And then in that heat exchanger, they cool down, and then they go through this fluorine cascade absorber towards the stack. And in the stack, they leave with about 150 degrees. So that means a delta T of about 300 degrees Celsius, 300 Kelvin, could be realized with that new heat exchanger. Before this retrofit with the old heat pipe system, only 150 degrees of delta T could be realized. So the hot gases left with about 300 degrees Celsius in the stack. Good. What is done with this recovered heat? Of course, then the hot air for the dryer was heated up. So fresh air is taken in here with this fan, and then is heated up from 20 degrees Celsius to 260 degrees Celsius with the heat transferred in the heat exchanger. And before the retrofit, it could only be heated up to 150 degrees. So that means there is another close to 100 Kelvin of a hotter temperature for the drying process. Good, let's come to the specialty of the heat exchanger again, which I already pointed out before. So if you directly flush the fresh air with 20 degrees into this heat exchanger, you will come below the dewing point of these corrosive substances inside the flue gases. So the trick, as you see in this light green pipeline, was to split up this stream towards the dryer. Of course, the major part is still going to the dryer, but some part of it is also guided to the fresh air intake and heats it or preheats it to the 100 degrees Celsius. So that means then you avoid this danger of condensation inside the flue gases, and that is an environmental and safety aspect. So here on the right, we also see the heat exchanger again, its working principle. The hot air comes in with at the red arrow here from the kiln, from the furnace, cools down to these 150 degrees and goes then through that large red pipeline towards the stack. And here the green arrow, we see the fresh air intake. It's preheated to these 100 degrees Celsius and then heated in the tube bundle up to these 260 degrees, which then go to the dryer. And it's really a huge heat exchanger. So there is a tube bank of 2,500 pipes inside. So that's really a large heat transfer surface inside that heat exchanger. So, but let's talk also about energy savings and money. So first of all, here we see the consumption of natural gas before the retrofit in 2015 and after the retrofit. So you see in 2015 with the old system, we had about 25 million kilowatt hours per year, which came from the natural gas. And after installing the new heat exchanger, these was only about 17 million. So these were savings of natural gas energy of about 30%, which is quite significant. And if you use less natural gas, then you will also produce less CO2, of course. So here there were also savings of about 20% of CO2 emissions. Comparing the two systems, we see, of course, we have the same volumetric flow rate because we want to produce the same amount of bricks. But what you see, the heat transferred with the old system was only 500 to 900 kilowatt. And now with the new system, it more than doubled. The heat transferred was more than doubling. That means also saving the energy from 3,200 to 16,000. So it's more than 4 times of saved energy in there, and that also means the savings of the CO2. So this is the current system of 2018, and now 8 years later, if you compare the numbers, the figures now, then you see the system still runs almost unchanged. So that means a loss of energy efficiency could not be traced up to now. So the plant, the recovery system works still like on the first day of after its startup. So final slide, talking about money, of course, which is also important. Did this pay back? Let's talk about the amortization period. Of course, as you save now natural gas in the dryer, you save also money for this natural gas. And that also leads not only to reduced amount of natural gas needed, but also to a reduced emissions of CO2. The only drawback in the amortization calculation is that you need this new circulation fan. You need additional electricity. However, this is a safety issue, a safety feature, so we have to include that into our calculation. And if we plug all those numbers into our calculation, then we see that the amortization period of this new recovery system is only 3.5 years. So that's really quite a short period for a payback. And this is even without funding. So if we would also include the funding by the government into this retrofit, the amortization period would even be smaller. And this was in 2018. It made already sense back then. But if you look now, 8 years later, the price of the natural gas has increased. Also, the price or the costs for CO2 emissions has increased. So you see this, this measure would even make more sense today. It made sense in 2018 and even more sense today. And that's the final message. As soon as you have waste heat in your production plants, you should always think about heat recovery. It's not only a benefit for the environment, safety issues, emitting less CO2, needing less fossil fuels. It's also a financial payback. So after a few years, you will get also back your payments and your investments. So thank you for your attention, and we are looking forward to your questions. Thank you very much.
Thank you, Professor. The first question you already answered. It was about how you reuse the heat you're saving. There's another question now that came in. How did you come up with the innovative solution of recycling air? Who had this idea maybe, and how was it?
Why is it an air-to-air system? Is this the core of the question? So that was because also the old heat pipe system, so it is an existing plant which was already applying an air-to-air heat exchange. So it just made it made best sense to also adhere to this air-to-air system and heat exchange again. So there were no other fluids like heat transferring oils or something like that used.
And the idea was developed within the company or in the collaboration between the university and the company?
No, that was only the company. So we have other corporations with the Schlagmann has other corporations with the university, but not in that field. So this was a pure development by Schlagmann, also initiated by Bernhard Schmiedhammer, and yes, so they designed the new heat recovery plant, and as an industrial manufacturer of heat exchangers, they had this company Helmich, where they closely cooperated to invent this very special heat exchanger. I see you're nodding, Bernhard, so I hope it's okay, and you can also add something if you like.
Thank you. And can I ask about the amortization period that you mentioned of, I think, 3.5 years, because that's usually a critical decision-making factor. So in your experience, what would be a maximum amount of years to recover an investment for a company to consider that investment?
So Bernhard, what would be the maximum amortization period you would have accepted in the company?
Ja, die Akzeptanz ist immer abhängig vom wirtschaftlichen Verlauf der Firma, aber in der Regel sollte es dann schlussendlich kleiner 3 Jahre sein. Und so sind auch diese Fördermaßnahmen gestaltet, dass wenn Maßnahmen über 3 Jahre sind, wird ein Zuschuss vom Staat gegeben. Das ist sehr sinnvoll. In wirtschaftlich schwierigen Zeiten schaut man, dass man es in 2 bis 3 Jahren schafft. Aber große Projekte müssen wohl auch über 5 und mehr Jahre laufen können. Wie man hier sieht, ist die Anlage läuft ohne Probleme seit 8 Jahren und hat sich aufgrund dieser Zahlen mehrfach bereits amortisiert.
So I quickly translate. Typically amortization periods should lie around 3 to 5 years. It's also a funding question behind. So typically there will be only government funding if there is a short amortization period, because only then it makes economic sense after a few years. So also in economically difficult times, of course, you can talk about changing the amortization periods, but if in a economically healthy environment, the amortization period should be between 3 and 5 years, and then also reaches your chances for governmental funding also for these projects.
Yes, if I could correct, I think Mr. Schmiedhammer said 2 to 3 years.
Yes, so 2 to 3 years. This is in economically healthy times.
Bei großen Projekten wird das wohl nicht zu erreichen sein. Und die Kosten für die Investitionen sind seitdem exorbitant gestiegen. Also diese Anlage würde man jetzt auch nicht mehr für 850.000 € bekommen. Wir haben ein anderes Projekt am Standort Ansbach gemacht mit einem anderen, mit einer Wärmeträgerölanlage, und da war das Invest bei 3 Millionen €.
So it's also, these short periods can also be, the shorter or the smaller the plant realized, the less amortization is possible. The larger the projects, the larger the amortization periods, of course, also because the investment is higher and it needs longer for the paybacks. But for projects like this size, the 2 to 3 to 4 years is quite normal.
And so if I understand right, you received government funding for the project, or this project was realized without government funding?
Da haben wir 230.000 € Zuschuss bekommen.
So out of the 50,000 euro investment, about 200 to 250,000 was government funding, as this was a significant utilization of waste heat.
Momentan ist natürlich der Betrag wesentlich besser, da die Gaskosten sehr stark gestiegen sind.
Mhm.
Aktuell haben wir über 4 Cent für die kWh. Früher waren das 2 Cent.
Mhm.
Thank you. Yeah, so Mr. Schmidhammer just added that the natural gas prices in Europe for industry have almost doubled from around 2 cent to more than 4 cent, which means that you can, of course, now save much more money by saving energy than you could in the past.
So yes, as we see on the last slide, it made sense in 2018, and it would even make more sense now as the gas prices have increased, CO2 emissions, the costs have been increased. So it would even make more sense today to realize such a retrofit.
Thank you. I just see one congratulation by a participant saying it was an extraordinary project.
Okay.
Thank you for sharing it.
Congrats are for you.
And maybe a last question. Will this technology work when the weather is very warm in a climate maybe like India? Is it resilient to heat?
Yeah.
Also ich würde da keine Probleme sehen. Ob jetzt Außentemperaturen von 20 oder 40 Grad sind, wird auf diese Projekte wenig Einfluss haben aus meiner Sicht.
So I think as the fresh air is heated always to 100 degrees Celsius to avoid the condensation inside the heat exchanger, it will not make sense. It will not make a change if the fresh air has only 20 degrees Celsius or it has 40 or even 50, because it will be always preheated to 100 degrees Celsius to avoid dewing and condensation.
Thank you. I think, being mindful of time, I would like to come to an end now. I have noted down a few questions that were addressed to Daria before. We will try to answer these via email after the webinar. Any remaining questions can, of course, also be addressed to us via email. Please reach out to the organizers of the webinar and they will forward your questions to us, and then we will come back to you. I would like to thank our speakers, first of all, the organizers of this webinar and all you attendees for participating in this webinar today. I would also like to point out that the next webinar we're organizing is happening on July the 8th and will cover industrial electrification and particularly industrial heat pumps as a topic. So that may be of interest to you as well. And with this, I would like to wish you all a good day and have a good weekend. Thank you very much.
Good day. Bye. Have a nice afternoon.